So all this work, this will be on the practice. We'll have actually two of those problems on the practice test today. Two of those find the equation ones. Be number 19 and 20, actually, the last two. So yeah, so today's game plan, I'm going to cover, I got to cover 3.7. That's the last section that's on the test, the practice test today, the real test tomorrow. 4.1, that's getting ahead. That's exam 3 stuff. I got to cover it. So we'll do that, hour and 15, maybe something like that. Practice exam for 45, then go over the practice exam for the last hour. Tomorrow I'll cover new stuff the first 2 hours, and the last hour we'll take our exam. Good? Are you up for that plan? All right. And that's the end of our week already tomorrow. Yeah, so that'll be 2 weeks. Wow, we're moving fast. All right. So let's keep going. Here's from 3.7. So here I have a question from 3.7. It's kind of a weird one. It's number 2. I'm going to jump into number 2 here. Number 2 from 3.7. They're saying determine if the thing's an answer. Determine whether the ordered pair is a solution. Is it an answer? How do you determine if, those two numbers with the comma and the parenthesis, if those two numbers are an answer, a solution? What do you do? Yeah, plug them in, huh? That just means plug them in. Yeah, and when you do, the first one's X, the second one's Y, right? Because X always comes before Y. It's alphabetical. So you plug the X in for X and the Y in for Y. Is that good? So we get 5, and then the Y, so it'd be minus 1/12, minus 7, and the X is 1/6. And it's supposed to be less than or equal to -4. Everybody good there? Can you all see? Maybe I should have written out the original one better. So it's 1/6 minus 1/12, and the original statement is 5y minus 7x less than or equal to -4. So there was the original. And this one's the X, this one's the Y. I'm plugging this in for X and this in for Y. Okay, so we get to here. Now, honestly, it's just all numbers. I would just hit the buttons on my calculator. See how it's just all numbers? There's no letters. So if it's just all numbers, just hit the buttons on your calculator. What I mean is, you guys have calculators with you? It'd be good to bring the calculator that you're going to use on the exam every day to class to get used to it. So 5 times -1 divided by 12. Fraction just means divide, right? So 5 times -1 divided by 12 minus 7 times 1 divided by 6. And then just hit the equals, or the enter, or whatever, on your calculator. And see what you get. It's going to be like minus 1.6 or 7 or something. You guys want to tell me what you get over there? -1.6? And then some other decimals after that? Or just directly 1.6?
That's 1.58.
58, okay. 1.58. Good enough. We good? So I just did this left side. Right? I just worked out the numbers on the left side, and it came out -1.58. So the question is the statement true or is the statement false? Is -1.58 less than or equal to -4? Is that true? To be sure, let's go to the number line. Here's 0. Here's -1.58. Here's -4. Like, think about money. $4 in debt is worse than $1.58 in debt, huh? So the -4 is the lower one. So this is saying the -1.58 is lower. No, that's false. The -1.58 is not the lesser, right? He's on the narrow side of the symbol. That's the wrong side. He shouldn't be on the narrow side. See right here in the statement, he's on the narrow side of the symbol. It's saying he's the lesser one. That's not true. He's not the lesser one. He's the greater one. So that's false. So this is just a yes-no question. So we would just say no, 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 it doesn't work. When you plug in the negative, the 1/6 and the negative 1/12, and you work it out, it doesn't work out to be true. It turns out to be false. So it's a no. That is not a solution. It's not an answer. That make sense? On that? We good? All right. I'm going to go. Okay.
The section 3.7 will be on the test, correct?
Right. That's the last section that's on the test. 3 plus, we're about wrapping up the test stuff here. 4x plus 5y less than or equal to 20. We're supposed to graph that thing. So what do you do first to graph that thing?
The y could be wrong.
Yeah, what we're always doing, huh? Y's got to be alone. So can you do that? Do the steps to get y alone. What's the first step I'm going to take?
Subtract 4x.
Yeah, subtract that 4x. So far, so good. Just subtract that 4x from both sides. And then what's the next step? It's just divide, right? Divide by 5, divide by 5, divide by 5. And 20 divided by 5 is 4. We all good to there? Everybody happy? Now, can we graph that one? Where, when you're going to go to graph it, where do you start? Yeah, start with the positive 4. But I should probably leave a little more room on the graph. Yeah, so go ahead and let me move this over. But you guys go ahead and graph it on the graph there. I'm going to move it over. Through, okay. So yeah, so you start at the 4, and that's positive 4, that's up 4, so right, did I miss? I missed a little bit. So up 4 right there. So there's up 4, there's my first dot. Okay, there's my first dot. Now, where do I go to get my second dot?
You go down 4,
Yeah, it's this fraction right here, it's the slope. Then remember what you do with a negative on a fraction? What do you always do with a negative that's on a fraction? We just put it on the top usually, huh? And that's rise over run. Remember how that works? So put the negative on the top, that's rise over run. So that means this goes down. So if you're right here up at 4 and you go down 4, you're at the origin. And then over 5, you'd be about right there, huh? Right between the 4 and the 6. That okay? You know what? I think I'm just going to, this graph, I just don't like the double marks. I'm going to just do my own graph. Yeah, let's just do my own. So I'll just do it here. So again, what was the first one? Up 4. So boom, right there at up 4, huh? That's the first one. And then how do you get to the second point? You go down 4 over 5. So you go down 1, 2, 3, 4 over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So right there. Everybody good with that? So that's where the second dot is. So the first dot is at up 4. And the second dot, you go down 4 over 5. There's your second dot. Then you just connect the two dots. You guys know all about this quite well. Connect the two dots. And that line keeps going and going, doesn't it? That's why we put the arrows. I'll just draw it for a long ways. There we go. That line just keeps going and going and going. Both directions forever. There we go. Except, there's one more wrinkle on this problem, huh? All that is exactly what we did yesterday. None of that is new. You knew all that, right? But yesterday, what's the difference between this problem and all the ones we graphed yesterday? There's one symbol that's different. Yeah, it's not an equal. Yesterday, they were all equals, huh? Yesterday, all of our graphing problems said equal. This one, that's what this section is all about. This last section in chapter 3, the last section on the exam tomorrow, is what do you do when you have like a less than or a greater than inequality in a graph? What does that do to the graph when you have an inequality? Does anybody know? What does that do to the graph when it says less than? Yeah, it's going to have shading. It's going to have shading. But I don't want to just say, hey, Mr. Heron says so. I want you to see why, because I think it'll stick with you better and you'll remember it more easily. So let's make sure, do you guys understand that when you do a graph, basically a graph is like a light bright. That's the perfect analogy, I think. Meaning there's a lot of different, remember that old toy where you plug in the different, the things in the different slots and they light up, right? So that's what a graph is like. And right now, we've got a whole bunch of points along this line that are lighting up. That's why the line is even showing up. Because billions and billions of points on that line are lighting up right now. Why? Why are they lighting up? Because they make it true. Basically, you're saying, hey, light bright, I want if you could talk to your light bright, I want every location that makes the thing true to light up now. That's what a graph is. A graph is an answer. It shows you all the locations that make it true. That's what the answer is. Okay, what do I mean? I want to show you a little bit more, but you don't have to write this down. But you want to if you understand this, it'll make good sense for you. Like let's take a dot on the. There's a dot on the line right there, huh? Let me just show you what I mean. There's one dot that is on the line that got to light up, right? What's the coordinates of that dot? Like the two. Remember, every dot has two numbers that make that one dot, right? That's 0, 4. Right. Everybody good with that? Because remember, the first number's over, second number's up. That's over 0, up 4. Boom. That dot's 0, 4. It's always x first, then y, huh? So what I'm saying is, if you take x 0 and y 4, and you plug it in, it'll make it true. I don't know if I have room. I'll plug it in right here. Let me. I don't have room. Here, let me just erase this and put the final thing, and then we'll work with that. I've done it twice now. All right, so what do we have? It's y less than or equal to, what is it, minus 4/5 x, and what was it, plus 4? Yeah, plus 4. Okay, anyway, what I'm saying is, if you take the 0, 4, and you remember this, 0 goes in for x, 4 goes in. You don't need to write this down, but you can just watch. If you put the 0 in for x, the 4 in for y there, it should make it true. Let's see. 4 less than or equal to. What is minus 4/5 times 0? It's a 0 there. What's minus 4/5 times 0?
0.
Yeah, anything times 0 is 0. That's just 0. 4 is less than or equal to 4. Yeah, 4 is equal to 4. It's equal. It's right on the money equal. That's why that dot got to light up, because he's on the line. He would have worked even if this said equals. Even if this was just equals from the beginning, right? That would be true, wouldn't it? Right? How about this other one? How about this dot over here? What's the coordinates of this dot right here?
5, 0.
Over 5, up 0, huh? Let's plug that in, x and y. That's going to make it true. Let's see it. Go back. Yeah, let's start over again. So it was less than or equal to minus 4/5 x plus 4. All right, so plug in now. What is it? 5 for x, 0 for y. Plug it in 5, 0. So 0 less than or equal to minus 4/5 times 5 plus 4. These guys cancel, don't they? Because that's 5 over 1. So what? Well, then you got minus 4 plus 4. What's that? 0. See how it made it equal again? See how I've checked 2 points on the line now. You get the idea. Every point. I can find other points, whatever this one. Find his x and his y, and plug them in, and it would make it equal. Do you understand? All the points on the red line make the left side of this equation equal the right side of this equation. Equal. The line is the equal, I'll just write right on it, equal territory. Now, other points didn't get to be on the line, right? Like, how about if I go up a little higher, right up here, over 0, up 7. That didn't get to be on the line. Why not? Is there a prejudice here? What's the membership requirement? You make the thing true. Huh. That's the membership requirement, right? You make it true. That's the simple fact. So let's go back up here and let's see, why is it that 0, 7 doesn't work? Let's see it not make it true. So if I put in 0, and I'm just going to pretend at first it said equals. Well, it doesn't matter what it says, but I'll leave it as it was, whatever. Put in 0 for x, right, because it's x first, then y. 7 for y, what we get? 7 less than or equal to minus 4/5 times 0 plus 4. 7 less than or equal to, this is 0, 4. 7 is less than or equal to 4. No, it's not. So 0, 7 did not get to light up. When I said light bright, everybody light up who makes it true. He doesn't light up. 0, 7's in the dark because it does not make the thing true, huh? Does that make sense? What does it make it doesn't make the left side equal the right side. It makes the left side too big, huh? Too big. So, what do you think the story is? I'm done plugging in points and fooling around. Do you see what's happening here? Any numbers that you plug in up here are going to be greater. Right? I plugged in 0, 7, and the 7 came out greater than the 4. Right? You with me? Anything you plug in up there is going to come out greater. Anything you plug in down here is going to come out less. Does that make sense? Greater and less. And anything right on the line is equal, huh? So really, there's 3 regions up there. Stuff above the line, when you plug into the equation, makes the left side greater. Stuff on the line makes it equal. Stuff below the line makes it less. So, what? Well then, final conclusion. What do they want from me? In the very end, what was my equation? It was y less than or equal to minus 4/5 x plus 4. Y less or equal. Less or equal. So they want from you, light bright, I want everybody to shine on, to turn on, that is less or equal. So where's that? It's everything down below. And the stuff right on the line, which is equal. That's our actual answer. So, long story short, the only difference between this and all the other ones we did yesterday is you got to shade the bottom. Sometimes you have to shade the top. How do you know? If it says greater. If it says y greater, you shade above. If it says y less, you shade below. Does that make sense on that? Are we good there? So I over-explained it, but I want to make sure you get the idea. So go ahead and so it's y greater than or equal to 3 minus 6. Can you go ahead and graph that one? That one, y is already alone, right? So we don't have to do any work to get y alone. Y is already alone. Can you throw that one on a graph? And then you decide which part to shade. All right, where do we start? Start at 3, yeah, because that's the number without the x, huh? So we start at 3, and that's up 3 in the middle. If it bugs you, you can rewrite it like this. This is how we're used to seeing it, huh? Right, the number that doesn't have the x is your starting dot. And if you don't have to rewrite it, but if it bugs you, go ahead. Start at up 3. So I'm going to do a graph right here. 1, 2, 3. Started up 3. There's our first dot. But I'm going to change it a little bit. And then find your second dot and connect the dots. So there's our starting dot. Up 3 in the middle. And then how do we get to our second dot? Yeah, this is 6 over 1, so it's rise over run. So go down 6, down 1, 2, 3, 4, 5, 6, over 1. There we go. Connect the dots. Good, like that. Well, my line's a little bendy, huh? There we go, a little better. Good, everybody good to there for that line? That's the stuff we did yesterday, right? You just started up 3 in the middle. Started up 3 in the middle because that's the number without the x. You go down 6, 1, 2, 3, 4, 5, 6, over 1. Connect the 2 dots. Now, so that's yesterday. The only difference today is we're going to also have shading, huh? Now, how do you know which side to shade? Well, you can't think right, left. I know it's tempting on this one, which is almost straight up and down to go right, left, but you can't. You have to think above, below. Why? Because y is alone. We got y alone. Well, because we're getting y alone, what does y have to do with? What does the y-axis do? Up and down, not right and left, huh? So it's all about y because y is alone. So you need to ask yourself which side of this black line is above it and which side's below it. Not right and left, but above it and below it. Well, it's tilted a little bit this way, right? Not much, but a little bit. So above is this side, isn't it? And below is this side. Does that make sense? Looking at the slight tilt of the line there. Above and below. No, there's above is greater. And below is less. Okay, so which side do we want? What is it? All you got to do is look at the last line with y there. Y is greater, right? So then I want to shade all the greater stuff. We're done. Well, let me show you how to do that on Math Excel as well. It's a little paint bucket tool. I'll show you. But is everybody good there first off? Does that make sense how I got the line and decided the shading? Y greater, greater shades above. Let me show you on the Math Excel. Hey, what do you have to remember when you're solving an equation as far as flipping the symbol? Yeah, so that's right. Good. You memorized? You guys all got that? When you divide or multiply by a negative, you got to flip the symbol. Good. So remember that when you divide or multiply by a negative, flip that symbol, which is going to happen on this one. So I'll give you a second. Try that one. Y saying I want to be alone. Y always wants to be alone. What's first step? Subtract 5x. Next step, how do we get y alone? Yeah, going to have to divide by -1. Look what I'm doing. I'm dividing by a negative number, so I've got to flip the symbol, right? See how I put a negative number? Divide by negative. Divide by negative. So flip the symbol. Divide by a negative, flip the symbol, so I flip the symbol the other way. Like that. Y greater than, and here we have two negatives, positive x, one positive, one negative, -3. We good to there? All right, now, can you graph it? So where do we start? Start at -3. Right? And then from there, we take the 5 and we put it over 1, and that's rise over run. So we go up 5 over 1, up 5 over 1, 2, 3, 4, 5 over 1. There's our other dot. Is that good for our 2 dots? So the first one starts at -3. Then I go up 5 over 1. Now we connect the dots. Like that. And now, which side of that line are we gonna shade? So now we gotta decide. Now, which side? It's got a slight tilt. It's tilted. We got to think above, below, not left, right. We can't think left, right. We got to think above, below. So if it's tilted this way a little bit, which side's above? The left side's above. This is above. This is below. Notice this is greater. This is less. Huh? Make sense? Because of the tilt, right? See how that is? It's tilted this way a little bit. So this is above. This is below. Okay. So which side do we want to shade? Greater. Yeah, all you gotta do is look at y on the, don't look at the beginning, look at the, because you might turn the symbol. Look at the last line, right? The last line when you got y alone, what does it say? It says y greater, right? Y is on the wide mouth side. Y is greater. So where's the greater stuff? Well, it's here. That's the greater. And there's one other tiny thing we have to do. Probably some of you already know. What do we gotta do with a line? Dash the line. Have you seen this before? Yeah, because technically, was everybody good to there first off? Does that make sense which side I shaded and everything? Right? It says y greater. Y is on the wide mouth side. So y is greater. Greater stuff is this way because the line is tilted. This side's above. So we shade above, shade greater. All right, now, last thing is, yeah, we have to make this line dashed. Why? Because they don't want the line. How do I know? They're not saying equals. They're just saying greater. See how that's, let me go back to the last problem. See the last one, they said greater or equal, remember? And go back to the first one even. This one also said less than or equal, right? That's the bottom of an equal sign right here. Less than or equal. Right, well, what's the equal? The equal is right on the line. Remember, the stuff right on the line is equal. Above is greater, below is less, but right on the line is equal. So if they have the equal, they want the line. But if they don't have the equal, they don't want the line. So this one, they wanted lesser stuff and the equal stuff, right? Less than or equal. So I gave them shading below, and I gave them a nice solid line. On the next one, they wanted greater than or equal, right? In the end here, they wanted greater or equal. So I gave them greater, I gave them above the line, and the equals, the line, the solid line. But on this one, they just want greater. Just greater. They don't want equals. So I give them just the shading above, but not the solid line, not the equals. So I dot the line. Like that. Make it a dashed line. Because you're saying the line is not part of the answer. I mean, you still have to have it there to serve as a border for the shading, but you don't include it in the answer. It's not really part of the answer. They don't want the equals. They don't want the line. They only want the greater. They only want the stuff above the line. There we go. Does that make sense? That's the whole section right there. Questions on that one? Are you all good with that? No questions? Okay. So, let me make that clear then. So if we have y less y less or y greater, dotted line. If you have y less than or equal or y greater or equal, solid line. Everybody tracking with me on that? If there's a solid bar, if there's the equal bar, you're going to have a solid line, huh? If there's no solid bar, you're not going to have a solid line. You're going to have dotted. So that's what I'm saying. Okay. Everybody got that down? And then I'll flash on to another. We'll do one or two more of these, then go on to the next section. If you're good with that. All right, try that one. Try number 3. That was a little tricky. So, what do we got? X greater than 3y. Try that one. I want you to graph it. It's going to have shading. You got a greater than less than. It's going to have shading. So what do you need to do first? Get y alone. Y needs to be alone. See if you can get y alone. So divide by 3, right? Both sides. Get that y alone. But then what do you do from there? Like, what's your starting number for graphing, I mean? Yeah, there's really a 0. So you could rewrite this 1/3 x plus 0. Right, you with me? Or I'll do this on the next line. So yeah, you could just say, look, it's 1/3 x plus 0. Is that good? So we're going to graph. So we start at 0. Here's our first dot, right on 0. And then where do we go from there? Rise over run. Go up 1/3. Right there, up 1/3. There's my 2 dots. Good, we all good? Connect them. Should I have a solid line or dotted? Yeah, it's not equal, so. So there we go. Dotted line, kind of. Dotted line. Oh, I need to show you do that math Excel. Yeah, I did. Anyway, now I want to get to there because I really want you to tell me, figure out on your own there if you shade above or below. Give you a second. Don't say it out loud. Give everybody a chance to look at that one. So. There's the lines. Everybody okay with getting that line? First off, start at 0, go up 1/3. Dotted line because there's no equals. We don't want the equal stuff. We don't want the line. We don't want the solid line. So now, shade above or below. What's that say? Yeah, all you gotta do is look at y, huh? Just look at y and say, hey, y. You don't need to turn the thing around or anything. Just look at y and say, hey, y, what side of the symbol are you? Are you on the wide mouth side or the narrow side? He's on the narrow side. What does that mean he is? Less. Does that make sense? Some students mistakenly think, I've heard it many times, that, hey, whenever it's this way, that always means greater. Well, no. It depends which side of the symbol the thing you're focused on is on. If you're on this side, you're greater. If you're on this side, you're less. Right? You can't just say one thing for the symbol always. No, just you got to look at what side of the symbol you are on. What side of the symbol is y on? He's on the narrow side. He's less. That makes sense? So y is less, so I'm going to shade the lesser things down below. Is that okay? Can I help with that? in any way? Just look at what side of the symbol y is on. It's all about y, isn't it? Getting y alone in this chapter. It's all about why y is less. Good? Are we good? I need something every now and then. I need like a, yeah, I'm good, or I am no good at all. Talk about that some more. Then I'll know whether, let's try that one. All right, so x minus y greater than 4. Try that one. We got y alone, as usual. Y wants to be alone. So what's the first step to get y alone? Subtract that x. Boom, it's gone. Good so far. Now what do we do to get that y alone? Divide by negative 1. Everybody see what's happening there? I just divided by a negative 1. Right? I just put a divide by negative, flip the symbol. Right there, I just divided by negative. So right there, I've got to turn the symbol the other way. Is that good? Getting the hang of that? So y is now less than, and I'll let you figure out the other side, and then graph it. So right here we have two negatives, don't we? Two negatives is positive, and then positive over negative is negative. Everybody good with that? So where do we start the graph? Negative 4. Right there, negative 4. And then what's our fraction? What's our slope?
1 over 1.
Yeah, you can just stick in a 1 over 1. When there's nothing in front of the x, it's 1 over 1. Because that's just 1, and 1 times x is still just x. We haven't changed anything. Rise over run. So that means go up 1 over 1. There's the next dot. Connect the dots. Here we go. There's our line. Everybody good there? So I started at negative 4, then I went up 1 over 1. Connect the dots. There's the line. Now, is it solid or dotted? Yeah, I should have made it dashed, huh? There we go. Dashed line because of the fact that they don't want the equals, do they? There's no equals bar. They don't want the equals. They don't want stuff in the line. So they want the shading above or below it. Look right here at y. Less below. There we go. Done. Is that good? Questions on that one? We'll do that today. We'll have these on the today's practice exam, like probably 3 of these. What's that? Oh, yeah. Can I show you that, huh? Oh. X less than minus 6. Go ahead and graph that. I want you to graph it with the shading and everything. What kind of line is it? Yeah, remember when there's only one letter? When you just have one letter, it's either perfectly horizontal or perfectly vertical. Remember that? We just have x. We only have x. So it's not going to, there's not going to be any sloping or any of that kind of stuff, right? When you just have one letter, it's just straight vertical, straight horizontal. How do you know which one? Well, you just go to the x-axis and throw a line through -6, huh? X-axis, where's -6? Right here, boom. Just shoot a line through the -6 on the x-axis. It's supposed to be solid or dotted? Dotted, dashed, because it doesn't have the equals, so boom, 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 like that. Okay. So there we go, like that. So far, so good. Got to do shading too, right? That good. Remember, when you only have one letter, it's just going to be a straight line, vertical or horizontal, through whatever it's saying. X-axis -6, x-axis -6. Shoot a line through there. Now, this is the one and only time I cannot talk about shading above and below. There is no above and below. That line goes straight up and straight down. I've got to think about right and left. Because there's no y. In the original equation, there is no y. I didn't get y alone. There is no y. I can't think about above, below. I got to think about right, left. Now, how do you know which way to go? Well, you tell me. Look at the x-axis. Where are the greater numbers? Aren't they over here to the right? Is that the greater stuff to the right, and the lesser numbers, the more negative numbers, -8, -10 are to the left? They're more negative. They're lesser. So, what does this say? What is this? It says x less. So you're going to shade the less side. There it is. We're done. Is that okay? Left is the less. Goes left.
So then in a sense, would it always be shaded on the left side?
No, if they had said x greater than -6, I would have shaded to the right. Because greater stuff is to the right. That makes sense? So whatever they're saying about x in the end, that's how you know which way to shade. X greater, greater is to the right. X less, less is to the left. Good. Are we happy with that? Are we like super happy? Does that make